also there. But another interesting topic is going to be AI in motion, revolutionizing manufacturing and transportation. And it's going to be presented by a person who is an ML AI expert at Manufacturing and Transport Center of Excellence from Ness Digital Engineering. Please welcome Dušan Stamenković.
Hello everyone, thanks for coming. I am Dušan. I am machine learning and AI expert at Center of Excellence at Ness for manufacturing and transportation industries, or short, M&T industries. And today what we will be talking about is AI and how it revolutionizes M&T. So let's get into it. It is crazy to think that 5,000 to 6,000 years ago, we only started riding horses, and today we can lay back in our car, maybe have a relaxing time with our significant other, have a little chat with them, and tell the car where to ride us, where to get us. And it does this on its own. So how did we actually get here? We will not go throughout the whole history, but we will definitely mention a few industrial revolutions that got us to this point. So first, at the end of the 18th century, we had an invention of steam engine, and we had water power. So those kind of technologies, those inventions enabled us to start mechanizing the production. So to move workers from their small communities into the factories and start really producing things in that way. Second industrial revolution came with the invention of electrical power. So these kind of machines powered by steam engine got replaced with electrical engines, with electrical machines. And together with assembly lines that were used by Ford, we start really mass producing stuff. In the late 20th century, we started using smart devices and electronic devices. So we started using robotics that really made this process of producing things really efficient. And in the early 21st century, close to today, close to present, these devices that produce data, they started being interconnected. So we started having Internet of Things. With Internet of Things come a lot of data, and we started doing a lot of things with this data. So store it, maybe use economies at scale like cloud. So we store this a huge amount of data into cloud and start analyzing it. So we're not only trying to store it, but also extract knowledge out of it. And here comes the AI and machine learning. So only 20 years ago, we have a rise, we had seen a rise of these technologies, and we are today living in the fifth industrial revolution, whether we like it or not. So what is this fifth industrial revolution all about? Well, first of all, we can start talking about human-machine collaboration. We have things like AR and VR, or a metaverse from Meta company. We have Neuralink developed by Elon Musk, and these things start to cure depression. So we have like human-machine collaboration in that sense. We have digital twins, so we can see what is actually happening in our city. So we have digital replica. We can see how the city behaves, how the traffic behaves during some big events, and not only store this data, but we can rewind the time and see how the things went. We also have, of course, what we already mentioned, self-driving cars. We tell them where we want to go, and we just go there. We can sit back, relax, and just get there. Also, what we'll be talking a little bit in depth more today is Copilot systems. So these are technologies like ChatGPT or Copilot in general that enable us to be much more efficient in our work, so much more productive. You can think about ChatGPT, you can think about Copilot, etc. Of course, I'm a manufacturing and transport guy, so why AI here? What is its role here? I will give you a small glimpse of it. So imagine that there is a company that has 1,000 trucks or even more, and they spend millions of dollars yearly to maintain those trucks. So by leveraging AI, they can expect up to 15% of reduction in costs. They can expect 20% reduction of unplanned downtime. So if they have a delivery service, in 20% they can be sure that it won't fail. And they can increase equipment life, whether those are machines, whether those are vehicles, etc. So those are all studies, and they show this kind of data, what can be expected. And where is Ness in here? First of all, we are a full lifecycle digital transformation specialist, which means that we take a project from ideation all the way through the maturity in long-term projects. So we got origins in Israel, so in 1999, and today we have over 4,500 engineers spread across 3 continents and 11 innovation hubs, so including New York, California, in Europe, London, Riga, Košice, of course, and we have also in Asia, we have offices in Bangalore, Mumbai, Hyderabad, etc. So now we will start talking about three specific use cases that we are working on and that we already developed that are relevant to these kind of technologies and these kind of industries. So starting with predicting the train's arrival time. There was a study done in New York that said that 70% of people at some point in their life were late to work due to a train being late. Now, we worked with a client who was from another metropolis, but the point still stands. And they use a static rule-based system that gave plus minus 7 minutes of error when the train will come. So imagine you are 3 minutes late, expecting the train will be late for 7 minutes, but the train got there 7 minutes earlier. So you were there for a good half an hour, being late to your work and explaining to your boss why are you late. What we managed to do is to lower this kind of error to 1.5 minutes to 3 minutes in up to 97% of cases by leveraging multiple machine learning models. Here in the red line, you can see a static prediction for a train being constantly either late, on time, or early for all stations as it goes through its trip. Green line is our predictions, and it follows the blue line, the actual train's arrival delay at each station very well. So how do we do this? We leverage technologies like TensorFlow, Keras, scikit-learn, and Pandas, and you leverage then Databricks, so cloud provider, to train all of these models efficiently and to build a flexible architecture that is flexible in a sense that we can add new features like CCTV data, IoT data, maybe some track failures. We can put in some data from the train itself, etc. So, and how do we leverage this data? So we are playing around with latitude and longitude, speed of train, what percentage of its trip is completed, what is the average delay at the main station, and we have feature extractors. So all of these data sources get extracted by feature extractors. They got concatenated into a single data set, and this data set is used to train a machine learning model. This machine learning model is deployed to an inference API, and we then start performance monitoring. So what this means is that we collect the predictions of a model. We collect, so it's predictions in a sense that this train will be early 30 seconds, but it got there early, let's say, 45 seconds. So we can use this kind of information that we are getting to improve the model over time, to retrain it and improve it. So this was one of the use cases that we did, and now we will move on to the second one. The second one is avoiding unexpected downtime for a fleet of trucks. Now, moving back to the image from the start, average price for maintaining your truck is 17 cents per mile. And it's very usual in USA that your truck passes around 120,000 miles per year, so which adds up to over $20,000 per truck to maintain it, to keep it running, and to avoid unplanned downtime. Our client has more than thousands of trucks, and they are all connected to a network. So by leveraging AI, he can get all the benefits that we already mentioned, and he can avoid unexpected downtime. How did we transform this business problem into a machine learning problem is we asked the question whether this truck will break in the next 1,000 kilometers. So let's first start with the data that we had. So as I mentioned, these trucks are all connected to a highly efficient network, and they emit a lot of data, starting from telemetry data, then going to failure data like SPN and FMI. Those are all codes, but you can imagine them as light bulbs being lit up in your cabin. So when there is something wrong with your engine, there is a red icon blowing up saying that there is something wrong with your engine, man. You should check it. Taking all of this data and pairing it up with repair history, we started forming positive and negative samples. So how we did this? We took those indicators, we took this telemetry data and put it into a history of last 5,000 kilometers, what happened with the truck in the last 5,000 kilometers. And based on this history, we are predicting whether there is a repair happened in the next 1,000 kilometers for a specific truck. If there is, this is a positive sample. If there isn't, then there is a negative sample. And now moving to solution, we leveraged AWS, so cloud provider, for training our model, and SageMaker, so this is their service that enables us to leverage MLOps and latest technologies and machine learning to have a very cool pipelines. So what are these pipelines? This is in the middle, and this is an automatic process of getting the data out of the data storage, training the model, pre-processing this data, transforming it in a way that I already showed you, training the model, evaluating the model, and if the model is good enough, if an engineer approves it, then we deploy it. The best part about this pipeline is that pipeline can be triggered, and pipeline can trigger different things. So they can be triggered by newest code changes, they can be triggered by new amount of data coming in the data sources, and they can trigger next things. So if we want to deploy it on a server, or if we want to deploy it on trucks themselves. We also leveraged explainable AI, so we want to know each feature, how it pushed the model towards bringing in prediction that this truck will need a repair in the next 1,000 kilometers or not. For example, kilometers bin, the first feature, if it is low, then it is pushing the model towards saying that this truck will not need a repair. If it's a high number of kilometers being passed, well, there are higher chances that it will need a repair. And this is a natural behavior. What we achieved is over 90% of accuracy. And now the client is deciding how to deploy this model, whether to go on servers or the trucks directly. And now moving to a true Industry 5.0 project, so Copilot Incident Response System. Our client is one of the major producers of locomotives and tracks, and they use legacy incident response system. It is not very user-friendly, so it is hard to use, and it is more focused on reporting incidents, whether there are some failures with the locomotives or some issue with the track. They need to report it and only then decide how to respond to it. And of course, by nature, it is much more reactive than proactive. And when an incident happens, engineer needs to log in, to search through the data, to search what really happened, make some kind of calculation, statistics, and only then make a response to the incident. Now, what we're building, what we started to build, is an Industry 5.0 project, so data-driven and AI-powered Copilot system. It will have predictive capabilities, so it will leverage machine learning to predict whether some kind of issue will happen, whether with locomotive, whether with track, or something third. Of course, it will leverage natural language processing to automatically generate reports and produce recommendations on how to resolve some incidents. Of course, also, it will monitor the whole system and send the alerts appropriately when some accidents either are predicted or are already happened. So how will this be achieved? First, of course, is working on data infrastructure that exists on the client side. We identify the existing data sources. Based on those, we either modify them, assess them, and build another new ones on top of them, and connect them to machine learning solutions, of course, maintain them as well. And this project will be built in stages. So each stage will bring more complexity, but much more value as well. So what we're starting with is rule-based system. This is a very simple to implement. It is also fast, and it will provide a very good baseline. In what sense? So it will still have these capabilities that we are talking about, but it will be built on top infrastructure that our client is using already, like OpenSearch in AWS. It will have basic machine learning and anomaly detection capabilities already. On top of it, we start playing around with machine learning and implementing it into the system. So here, we will start building custom data pipelines to support these models and to enable things like predictive maintenance. So similar to trucks, we have locomotives that are connected to a network, and they produce data that we will be used to predict whether there will be some issue with the locomotive. We will use NLP to summarize reports, to do sentiment analysis of operators of locomotives. So when they're riding, they make a call to the call center, and there is a panic in their voice. Well, our NLP models will detect the sentiment, detect the unease in their voice, and send an alert. We will also transcribe the calls, so this is all then can be searched and can be asked through the Copilot system later down the road. We'll also use computer vision to identify damages to tracks, and to locomotives, and to classify different incident types. And in the final stage, we will start leveraging large language models and generative AI to provide a conversational interface to engineers. So they will come up to their work, put on headphones, and start talking to the system to see whether there was something wrong that happened yesterday, or whether it will predict that something wrong is already happening. We plan on extracting information not only from text, but also from images and videos. So there are now models that enable you to describe what is in this image, or to explain you what is happening in this video. So how can you imagine this Copilot? Today we are living in the explosion of generative AI and Copilots in general, and a lot of companies are working on those. So there are now Office 365 Copilot that enable you to write your things more efficiently and make you more productive. There is now GitHub Copilot that enables you to code more efficiently, to code quicker and better. And also now Google, a couple of months ago, unveiled their healthcare Copilot that doctors use to talk with their patients, to get recommendations on what can they do, etc. On our side, we will use it for engineers and for locomotive operators to talk about their system, their locomotive, etc. And how does this work? There are two parts of talking with your data, talking with your knowledge base, and we will go through them now. First part is getting your data into a knowledge base. So on the left, top left, you can see you have your own private data sources. So starting from videos, PDF files, presentations, databases, whether they're SQL-based databases or no SQL databases, doesn't matter, text file, Confluence pages, and we extract text out of these data sources. This text is then split into data chunks, and data chunks are pushed through large language models. They produce the vector representation of this text and send this vector representation in vector database. Now we are ready to go into the retrieval stage. So we ask a question about our knowledge base, and the question gets pushed through the same large language model and ask the vector database, what are the most similar things that you know that I can use to reply to this question? We get several answers, we refine those, large language model refine those answers with, of course, access to the memory of the conversation, so you can lead a meaningful conversation with your knowledge base and gives us back the answer. So, going to the future of AI and manufacturing and in manufacturing and transport, and to conclude this presentation, so going back to the beginning. In a couple of thousand years, we went from riding horses to being ridden by cars wherever we want to. And this all happened in the last, let's say, 100 years. Also, what can be noticed is that these industrial revolutions are happening quicker and quicker. First one happened in the 18th century, second one in the 19th, and the last three happened in the last 30 years. So changes are happening quicker and quicker, and AI is having a bigger and bigger impact in our lives, whether they are through some kind of models like ChatGPT, or in the industries themselves, whether it's healthcare, whether it's manufacturing and transport, all kinds of things. You can also think about this kind of vehicles as well. 30 years ago, we produced car on the right, so a blue one, and today we are producing brand new Teslas that can drive us where we tell it to. So, to me, it's a very exciting time, and I expect it to become even more exciting, and that AI will play even more significant role in our lives. So, thank you very much for your attention, and please, what are your questions?
Thank you, Dušan. Talking about Tesla, we've got 3 Teslas here today. I don't know if you know.
Didn't know
Have you tried it?
Sadly, not yet. Maybe I will after the conference.
There is still a chance, I think, so also for you, if you want.
Exactly.
Slide is on again, so if you want to ask, you can ask questions through it. I think that's a very great advantage of these processes. Like, okay, you will see how long the train is going to be late, etc. But what are the maybe the disadvantages? Like, what are you coping with some problems when working on these solutions?
Of course, there are always engineering problems and tweaks that need to be made to a system in order to get it working. But other than that, there are no really significant issues with using AI.
We've got a question. Model is evaluated by engineer, and if approved, then deployed. What and how is engineer evaluating? Can it be automated?
That's a great question. So, if you remember, we have a SageMaker pipeline that trains the model, and it evaluates it on the newest data. So, what we want to approve is to check the metrics, whether it is accurate enough, whether it's performing much better than the existing model, and based on that we can make an informed decision, whether we talk with our client, with our team lead, and we approve it all together. So this is the reason why we want an engineer to be approving it. Of course, we can make it automatic as well if the model is performing better than just deploy it. But this is the standard practice.
What are the challenges for you and your team maybe now? Do you have any new projects they're working on right now?
There are always new projects from different industries. So, but yeah, other than engineering issues, those are sweet troubles. Other than that, not really issues.
The old Lada could be only stolen, not being hacked as today's Tesla. What is more dangerous for us? Very good question.
That's a good question, yes, and a good observation. I am still not driving a self-driving car, maybe in a couple of years, but until then, I'll tell you that both of them here have upsides and downsides. So whether you want to drive a Lada or a Tesla, depends.
I think that's the same as the presentation we had before with social media and these things. You know, if you don't want, okay, don't use it, but then like you may miss some things, and you always have in mind the risks it can.
Yes, it's always upsides and downsides. So upsides is you can lay back in your car and tell it where you want to go. But on the other hand, it can be stolen. It can run out of battery. Of course, things are improving as everything we are doing as a species, let's say. And I expect it to become better in the future.
Okay. Are you staying here with us for the rest of the
Yes,
presentations?
yes.
Okay, so again, there is a coffee break coming now. So if you want to ask something also for Dušan, if you have any questions, you can also have a chit chat with him. Thank
Yes,
you
of
very
course.
much. That was
Thank
Dušan
you.
Stamenković.